So welcome students. So now that you have learned the topics of trigonometric equations, so let us move on to our next topic, trigonometric inequations. So now, what are trigonometric inequations? These are nothing but trigonometric equations where equality is replaced by the symbols greater than or equal to, less than or equal to, greater than or less than. So if you use some of these symbols, then we call the equation as an inequation. For example, let us take a very simple trigonometric inequation. Sine X is something like greater than or equal to half. You're asked to solve this. So in trigonometric inequations, while solving them, we use a beautiful property of trigonometric functions, which is called the property of periodicity. So we know that trigonometric functions repeat after certain amount of interval. That is, if you take Sine X, if you take the graph of Sine X, so we know that the graph of Sine X looks like a wave, right? Looks like a wave, and the numbers, if you write 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, so on. So this graph goes on like a wave, and if you take this part of the wave, the part of the wave between 0 to 2 pi, you can consider this as a basic wave, and you can think of this wave getting repeated again and again. So the same numbers are repeating again and again. So the period of Sine X is said to be 2 pi. The interval after which the values of a function repeat themselves is called the period of the function. So Sine X's period is 2 pi. That is, sine of x plus 2 pi will be again equal to Sine X. That is, if you take any value x, if you increase the value of x by 2 pi, you get the same functional value. It is the value of Sine X repeats after an interval of 2 pi, right? So 2 pi is the period of Sine X. In this way, all trigonometric functions repeat after certain intervals. Interestingly, if 2 pi is a period of Sine X, I can also say 4 pi as a period of Sine X. Because if I take this as a basic cycle, this cycle repeats itself. I can say that this has a basic cycle. So this cycle is also repeating itself. Hence, if 2 pi is a period, all multiples of 2 pi are also periods. And the least of all these periods is called the fundamental period. The least period is called the fundamental period. So for Sine X, the fundamental period is 2 pi. I cannot go less than 2 pi, because if I go till pi, this graph is not repeating itself. So the basic cycle is a cycle of length 2 pi. I don't need to take exactly this part of the cycle. I can also take this part of the cycle. So I can say that this part of the cycle is also repeating itself. So any continuous interval of 2 pi, so if you take for Sine X, we can think of it as repeating itself. Hence, 2 pi is the fundamental period of Sine X. So in this way, different trigonometric functions have different fundamental periods. So I will write the periods. So Sine X, the period is 2 pi. Cos X, the period is also equal to 2 pi. And if Sine X repeats after 2 pi, cosecant X also repeats after 2 pi. Secant X should also repeat after 2 pi, right? But for tan X and cot X, the fundamental period is pi. So you can go to the graphs and look for the fundamental period. What is the interval of tan X which you need to take such that the graph repeats itself? So the graph of tan X repeats itself after every pi units. That is, tan of x plus pi will be equal to tan X. So if pi is a period, 2 pi is obviously a period, but pi is the fundamental period. But for sine, cos, cosecant and secant, 2 pi is the fundamental period. So we use this property of periodicity to solve trigonometric inequations. So let us see how we do this. For example, let us take the inequality Sine X greater than or equal to half. So how do we solve this inequality? So the process is, so first step, I draw the graph of Sine X. Draw the graph of y is equal to sin x. If sin x is given, draw the graph of sin x, cos x, tan x, whatever is asked, first draw the graph of the given function. Next, identify the points where the equality holds. That is, first identify the points where sin x is equal to half. So forget about the inequality in the starting. Just draw the line y is equal to half. That is, y is equal to what our number is given. That means sin x is equal to half. That means y is equal to half. So if you take half lies somewhere here. So you draw a horizontal line corresponding to y is equal to half. Now, try to solve the inequality in one complete cycle. That is, a length equal to the fundamental period of whatever function is being considered. For sin x, we know that the fundamental period is 2 pi. So take some interval of length 2 pi. So for example, let us take 0 to 2 pi. This is 0, this is pi by 2, this is pi, this is 2 pi. So solve the inequality in this interval. So we know that sin x is equal to half. This value is pi by 6, 30 degrees. And this value is 5 pi by 6, 150 degrees. Pi by 6 and 5 pi by 6. Now, I want my value of sin x to be greater than or equal to half. So I want the graph to be above the vertical line. That is, this horizontal line represents y is equal to half. That means all the points on this line satisfy the condition sin x is equal to half. Now I want sin x to be greater than or equal to half. That means I want the interval where the graph of sin x is above this line. That is the interval pi by 6 to 5 pi by 6. And this is the solution of this inequation in one cycle. Because in the next cycle I am getting another interval. In the previous cycle I get another interval. In the next cycle I'll get another interval. So I'll go on getting intervals in each cycle. So in one cycle, if I solve this inequality, the value is x belongs to closed pi by 6, because you have an equality here, to 5 pi by 6. So this is the solution in one cycle. Now what is the solution in the next cycle? Obviously, if sin x is equal to half at pi by 6, due to periodicity, it will be equal to half at exactly this point at a distance of 2 pi from this. And 5 pi by 6 corresponds to this point moved at a spacing of 2 pi. Similarly, this point corresponds to this moving back at distance of 2 pi. This point corresponds to this point moving back by 2 pi units. And if you want to go to the next cycle, you need to add again one more 2 pi. That means effectively you're going 4 pi units forward. This is also going 4 pi units forward. Next step, 6 pi units forward, 6 pi units forward. That means you go some number of times the fundamental period. So graph of sin x, draw the horizontal line, solve in one cycle, you get the solution, and just add n times t to both the limits, both the extremities. That's the final solution. That means the final solution will be x belongs to 2 pi times n. N times the period of sin x is 2 pi. So 2 pi times n plus pi by 6 to 2 pi times n plus 5 pi by 6. So this will be the answer to this question. So if you put n is equal to 0, you get the interval pi by 6 to 5 pi by 6. If you put n is equal to 1, you get the next interval 2 pi plus pi by 6 to 2 pi plus 5 pi by 6. If you put n is equal to 2, you get the next interval. N is equal to 3, next interval, so on. And if you put n is equal to minus 1, you get this interval. So, and this goes on. And here n belongs to integers z. So this will be the final solution to this inequality. And whatever inequality is given, we follow the same process. First, we draw the graph. We draw a horizontal line corresponding to y is equal to number given here. Next, we solve the inequation in one interval, and then we add n times t to both the extremities. So once you do that, the solution for the inequality is complete. Now let us look at this inequality. You're asked 2 cos square theta plus sine theta is less than or equal to 2. You're asked to solve this in this interval pi by 2 to 3 pi by 2. So this is not a very easy inequality like we have seen in the previous example. So this has both cos square and sine. So the first thing that we try to do is we try to convert this inequation completely into one trigonometric ratio. So you can try to convert cos square into sine square or sine into cos. The better way is to convert cos into sine, because if you convert sine into cos you get a square root unnecessarily. So 2 times cos square is 1 minus sine square theta plus sine theta is less than or equal to 2. So 2 minus 2 sine square theta plus sine theta is less than or equal to 2. This 2 and this 2 gets cancelled. So if you carry over everything onto that side, 2 sine square theta minus sine theta is greater than or equal to 0. This implies sine theta times 2 sine theta minus 1 is greater than or equal to 0. Sine theta times 2 sine theta minus 1 is greater than or equal to 0. This implies, so the product of two numbers have to be positive. So if the product of two numbers is positive, then the condition is either both of them can be positive or both of them can be negative. So sine theta greater than or equal to 0 and 2 sine theta minus 1 greater than or equal to 0, or either both these can happen, or sine theta less than or equal to 0 and 2 sine theta minus 1 is also less than or equal to 0. So if you take this case, sine theta has to be positive and sine theta has to be greater than or equal to half. So what is the common solution to this? It has to be positive and greater than half. That means the common solution is sine theta is greater than or equal to half. And sine theta less than or equal to 0 and sine theta has to be less than or equal to half. So sine theta is less than 0 and less than half. What is the common solution for this? Sine theta is less than or equal to 0, right? So if this is less than 0, it will automatically be less than or equal to half. If it is greater than or equal to half, it will automatically be equal to greater than or equal to 0. So the solution is either sine theta less than or equal to 0 or sine theta greater than or equal to half. So what we do is we try to solve these two inequalities. First, we draw the graph of y is equal to sine theta from 0 to 2 pi. That's sufficient. I don't need to draw a complete graph. Let me draw one cycle 0 to 2 pi. So if you want to solve this inequality, first draw the line y is equal to half. So y is equal to half. So it cuts the graph at 2 points. It means at these 2 points, the value of sine is equal to half. This is pi by 6. This is 5 pi by 6. So in between these two, as you can see, I want sine theta greater than or equal to half. It means I want the graph to be above this. So the answer to this is, in the first cycle, is sine theta belongs to closed pi by 6 to 5 pi by 6. And for the second one, sine theta is less than or equal to 0. Sine theta is less than or equal to 0. So where is sine theta less than or equal to 0? So just draw y is equal to 0 this time. I want my graph to be below this y is equal to 0. That means this part. So union, either this or this is nothing but pi to 2 pi. So if theta, this is the value of theta. So if theta belongs to pi by 6 to 5 pi by 6, both of them will be positive. Both these quantities is positive and effectively is greater than or equal to 0. If theta belongs to pi to 2 pi, both of these will be negative, hence the product will be positive. So the solution is either this or this. So I want the solution between pi by 2 to 3 pi by 2. That means I want the solution from pi by 2 to 3 pi by 2. So what is the solution between this? So I can have a solution like pi by 2 to 5 pi by 6. The required solution is pi by 2 to 5 pi by 6 or pi to 3 pi by 2. So both of these are valid solutions. if you want the general solution, if you want the complete solution, what you just need to do is, for this 2n pi plus pi by 6 to 2n pi plus 5 pi by 6 union 2n pi plus pi to 2n pi plus 2 pi. So this will be the combined solution, combined general solution to this inequation. And if you want the solution between pi by 2 to 3 pi by 2, this will be the answer. Thank you.